Welcome back. In this video, we are going to calculate the x-intercepts of a quadratic equation, or depending on the notation, it might be a quadratic function. Let's recall the x-intercepts of a linear equation, of a line. Well, the x-intercept of a line or a linear equation is where the graph of the line crosses the x-axis. And we would solve for the x-intercept by setting y, or our output, or f of x, whatever the case may be, they're all the same, equal to 0. So regardless if it's y or f of x, that will be written as the ordered pair, sum x-intercept 0. So we set y equal to 0 and solve for x. Well, quadratic equations, the graph of quadratic equations would be a parabola. Okay, a parabola is something that looks like that if it opens upwards, or it could open downwards. It can even open up sideways, right and left. But the ones we're going to work with are going to either open upwards or downward. So standard form of a parabola, we have our quadratic term is the one with x squared, or is the second degree term. That's our quadratic term. It has a coefficient of a. Our linear term, it's a first degree term. It has a coefficient of b. And our constant is c. So standard form of a quadratic is ax squared plus bx plus c equals 0. And standard form, well, it is equal to 0, but you'll also see quadratics written as y equals ax squared plus bx plus c, or f of x equals ax squared plus bx plus c. And the x-intercepts of these parabolas are, again, the points at which the parabola crosses the x-axis. So with a parabola, it's possible to have 0, 1, or 2 x-intercepts. Now this is assuming that our parabola either opens up or down. Okay, so what I mean is if I have my coordinate plane, I could have a parabola with just one x-intercept. Okay, where it just hits the x-axis. Right there, right at what we'll call the vertex. Okay. Another possibility, the parabola could still open upwards, and it might have 2 x-intercepts. There's one x-intercept, and here is the second x-intercept. And of course, it's possible for a parabola to have 0 x-intercepts, and now this is not to say all parabolas that open down have no x-intercepts. They could open up here, and have no x-intercepts. But we could have a parabola that looks something like this, opens down, never crosses the x-axis. Well, our process for calculating the x-intercepts is exactly like our factoring process. Okay, first check to see if the equation is already factored and equal to 0. If it is, set each factor equal to 0 and solve. Otherwise, what you'll want to do is get the equation into standard form. Okay, ax squared plus bx plus c. So decreasing order of x, and then what you'll want to do is set it equal to 0 and factor it. And then we set each factor equal to 0 and solve. And then we would write our answer as an ordered pair. So, as you see, this is something we have done time and time and time again. We've been factoring and solving quadratics. Well, what we've been doing is we have been finding the x-intercepts of a parabola. So let's go ahead and do the sample problem. Let's take a look at y equals 2x squared minus 7x minus 15. And let's find the x-intercepts of that. Well, what we need to do, it's already in standard form, so we'll set y equal to 0. We want to know when our output is 0. Okay? So that means we have 2x squared minus 7x minus 15 equals 0. So we'll go ahead and factor this. I'll factor this by grouping. I need factors of negative 30 that add up to negative 7. So those factors will be negative 10 times positive 3. And sure enough, that works. So I've got 2x squared minus 10x plus 3x minus 15 equals 0. So I've just rewritten negative 7x as negative 10x plus 3x. I will go ahead and factor this by grouping. I've got my two pairs here. So I'm going to factor a 2x out of my first pair, and I'm left with x minus 5. So I'm hoping to have x minus 5 left out of my second pair, and sure enough, if I factor 3 out, I'm left with x minus 5. And it's still an equation equal to 0, so keep your equal sign. And we get 2x minus 3 times x minus 5 equals 0. So I've successfully factored it. It's set equal to 0, of course. Then I set each factor equal to 0. 2x minus 3 equals 0. X minus 5 equals 0. And solve each for x. So I add 3 to both sides. 2x equals 3. And x equals 3/2. And I made a mistake here. This is 2x plus 3. So I subtract 3 from both sides. So I get x equals negative 3/2. And x equals 5. So my x-intercepts are negative 3/2 and 5. So they're the ordered pairs, negative 3/2 when x is negative 3/2, y, or my output, is 0, isn't it? And my other ordered pair is 5, 0. So if I were to graph this particular parabola, and 1, 2, 3, 4, 5, I have an x-intercept of 5, and I have an x-intercept of negative 3/2, and my parabola would look something like that, with my two x-intercepts, one at negative 3/2 and one at 5. So there's an introduction to calculating the x-intercepts of a quadratic equation, and we will see you in class.